Okay, so this is problem 1.3 out of Griffith's Electrodynamics, and it says to find the angle between the body diagonals of a cube. So the first thing we want is to get a picture of what it is that we're trying to find. So I just drew that over here so you can visualize what actual angle we're looking for. So that's the first step. So now let's start with up here. This vector, which we'll call A. Oops, don't want text mode. Which we'll do it over here then. This vector that we call A, it originates, if we let our origin just be down here, let's do it a different color, maybe blue. Maybe we let that be the origin. Then our vector A here starts at the point 0, 0, 1, and it concludes at the point 1, 1, 0. Okay? Vector B, we can do the same thing, only it's originating at the point 0, 0, 0, the origin, and it's concluding at the point 1, 1, 1. Okay. So now what we can do is we can write this vector in terms of our notation. Okay, so let's do that. So for vector A, right, final minus initial, so 1 minus 0, x hat, plus 1 minus 0, y hat, plus 0 minus 1, z hat, gives you x hat plus y hat minus z hat. So that's for vector A. Vector B, again, you can do the same thing, except it'll be 1 minus 0, x hat, plus 1 minus 0, y hat, plus 1 minus 0, z hat. And that's just going to be x hat plus y hat plus z hat. Okay? So now what we're going to use is our formula for the dot product, which says that if you dot two vectors, the dot product between the two vectors is equal to the magnitude of the two vectors times cosine of the angle between them. And the angle between vector A, I think I did this as vector, no, that's actually vector B, and vector A is theta, which is exactly what we're looking for. Okay. Well, what's A dot A? That'll be just 1 times 1 plus 1 times 1 plus 1 times negative 1. So that's 1 plus 1 minus 1, which is just 1. So this is what A dot B is. So this side of the equation is equal to just 1. The magnitude of A is 1 squared plus 1 squared plus negative 1 squared, square root, which is just the square root of 3. And likewise, we can find the magnitude of B as the square root of 1 squared plus 1 squared plus 1 squared, which is also the square root of 3. So now if we go back to our main equation here, the dot product equation, we have A dot B, which here we just concluded to be 1, is equal to the magnitude of vector A, which is root 3, times the magnitude of vector B, which is also root 3, times cosine of theta. Well, root 3 times 3 is just, root 3 times root 3 is 3. So moving that over, we have 1/3 equals cosine theta. Or alternatively, theta is cosine inverse of 1/3. Which, if you plug that into a calculator, is about 70.53 degrees. Okay? So I think the biggest trouble with this problem is this diagram that I drew here, well, over a picture, because I can't draw a cube very well. Once you have that picture down and you know that you're going to be using a dot product, it's pretty straightforward. So once you do that, you just find out everything you need and then plug it into your dot product equation to get your answer. So hopefully that helped, and if it did, please leave a like and subscribe. Thank you.